Hello and welcome to another one of D's ADD videos. Today we're going to be talking about the concept of linear combination of vectors. When taking linear algebra or matrices, you might be asked to determine whether or not a given vector is a linear combination of other vectors. What does that mean? Well, that basically means that some vector u can be rewritten as a combination of different vectors. Squeeze that C in there. Let's make that prettier. Okay, so how are you going to go about doing this? Well, you'll be given three vectors, and you will basically put C1 times the first vector plus C2 times the second plus C3. Let's just say there's three vectors for this explanation. And what will end up happening after you distribute and you end up grouping them, you will end up with a system of equations that has the vectors that are rows becoming columns. So the rows will become the columns of your system of equations. What do I mean by that? Alright, the easiest way is for me to just pick some numbers instead of confusing with a bunch of letters. This is straight out of the textbook here. We have the vector v1 is 1, 2, 3. v2 is 0, 1, 4. And v3 is 2, 3, 8. And we want to know if we can write vector 1, 5, 9 as a combination of the ones above. Okay. So what do we do? Well, if we were to do 1, 5, 9, we want to know if that's going to equal C1 times 1, 2, 3 plus C2 times 0, 1, 4 plus C3 times 2, 3, 8. And then after you do that, what you're going to do is you're going to end up distributing your constants through, and after you distribute through, you're going to end up grouping them through addition. So if you were to add just the x spots after you've distributed, you'd get one equation, and you'd set it equal to 1, because that's the x spot of your combination vector. And then you would do the 2c1 and the 1c2 and the 3c3 would be equal to 5. Okay? And when you do that, you'll end up with this system of equations. Here, I'll just go ahead and do it. Since it's an explanation video, let's just go ahead and be precise. It'll take just a second. It's not that complex mathematics. We're just distributing through again. and then combine your x values, your y values, and set them to equal to the corresponding part of your left side of your equal sign. So in this case, the x values would be this, and I'd set it equal to that. That would be my first equation of my system. Then what I would look at is the second spot. And that equation would be and finally, looking at the third K spot, or the Z dimension, you would have Alright, now let's notice something though. What happened, what should have happened is the rows became columns, and I noticed that right away. I'm missing a 2. It should be right here. Let's see where I made a mistake. This would be the first equation, right? So the second equation right here should be for the y positions, and sure enough there's a 2 right here that I just didn't write down. Okay, so be careful. It's quite early in the morning, so I'm allowed to make such mistakes, but don't make mistakes like that on your test. I'm thinking about the breakfast I should be cooking right now, but that can wait. Alright, so what was I saying? I was saying that the rows should become columns, right? So let's look at this. Did that indeed happen? The 1, 2, 3. There's a 1, 2, 3. Then 0, 1, 4. There's no C2 spot here. I should have left a space, but I didn't. And then 1, 4, 1, 4. Yes. 3, 4. One second over there. 3, 4, 8. And then we have a 2, 3, 8. Ooh, that's not good. I must be half asleep here. So let's see where I made a mistake. The third position, the first one should have been the 3. Oh no, I'm right. I'm sorry. It should be 2, 3, 8. 2, 3, 8. Right? I see it. 2, 3, 8. 2, 3, 8. I don't know where I came up with the initial numbers. Alright, so indeed it can be a linear combination. Then what you do is you do your row operations, and after you do your row operations, you should come up with what those constants C1 in this case would be 3. You can test out your row operation skills if you want to. 2 and -1. That's not what this video is about. What I recommend to you is to save yourself some time when you're given a problem like this. Go ahead and go directly from these row vectors into the column equations and set up your coefficient or augmented matrix, not coefficient matrix, right? And then do your row operations and find your C1, C2, C3. Okay? If you can find C1, C2, C3, then indeed it can be written as a linear combination. In this case, we would have, we could write out a final answer if we wanted to, like this. 1, 5, 9 indeed is a linear combination, because C1 was a 3 times the 1, 2, 3 vector v1 that we had originally, plus c2, which is a 2, times the 0, 1, 4 vector, plus the 3 times the 2, 3, 8 vector. Alright. So you might be asked to, my puppies are going crazy downstairs, so I apologize. But you might be asked to do this with functions or matrices as well. Those are separate videos. But for now, just make sure you're able to determine whether we have linear combination of vectors or not. I hope that clarified any confusion you might have. Please check out other example videos for further clarification. Thank you and have a nice day.